In our last video, we left off with example 3, so let's pick up back again with example 4. When we're solving this equation, we look at the fact that they want the answers between 0 and 2 pi. Remember, 0 can be included, but 2 pi cannot. When I look at this problem and I'm trying to isolate theta, I'm going to take the inverse cosine of both sides. So let me write the problem and recognize that in order to undo the cosine operation, I'm going to do the inverse cosine of both sides. So inverse cosine undoes cosine, leaving me with theta minus pi over 4. Where is the inverse cosine of 1? Look at your unit circle, find where your cosine value is 1, and recognize that that happens at 0 and at 2 pi. I probably should write both answers down, but I know that this particular problem is going to be adding more to my answer. So if I write 2 pi as an answer and I add more to it, I will have left the range of 0, or the domain of 0 to 2 pi. So I'm going to write down just the 0 answer. Last time we talked about how we could use the general formula. I could write this as plus 2 pi k. That would be fine. But once again, if I'm adding 2 pi already to an answer, I'm going to be leaving the domain that's allowed. So I'm just going to add pi over 4 and find that solution will work. If I added 2 pi to that to find another answer, because we know that the general formula, let me go ahead and write it, the general formula would be 0 plus 2 pi k. We add pi over 4, that would be theta equals pi over 4 plus 2 pi k. That if I add 2 pi, I'm leaving where I'm allowed to have my answers. So this particular problem had one single answer at pi over 4. For question 5, they ask us to use a calculator. Well, when you pick up your calculator and you have cosine of theta equals 2, or 0.2, sorry, and you solve for theta by doing the inverse cosine of 0.2, the calculator is going to give you an answer, and that answer is 1.37 once you round. Now, the problem here is that they want all possible answers between 0 and 2 pi. And when I draw my coordinate grid, and I recognize that 1.37 radians, remember radians would be 0, 1.57, and 3.14. That's the decimal versions of pi over 2 and pi. Then 1.37 is in quadrant 1, right here. 1.37. Where else on the unit circle is the cosine value going to be a positive 0.2? And remember that cosine is positive in quadrants 1 and in quadrant 4. So I've got to find another answer. Well, we talked about this in class, that when I have 0 or 2 pi, that's the name of this, that if I put it in decimal form, that would be 0 or 6.28. And I need to subtract the reference angle of 1.37. Should I subtract that from 0, making this a negative value, or subtract it from 6.28? Well, for that, we're going to go look at our domain right here. And the domain says that at the smallest value is 0, and the largest is 6.28. So we're going to subtract 6.28 minus our 1.37, and that will give us 4.91 radians. So the other answer is theta is equal to 4.91 radians. Okay, let's move on. I'm going to skip the second page for right now, and we're going to move on to example 8. Now, and you'll see why probably on the next video. We'll have to take another video to do page 2. But when we look at this page, this is different. This is a quadratic problem. Now, it's a quadratic problem with a single function. There is one type of problem to work with. And pretend for just a second that this is 4x squared minus 3 equals 0. How would you solve for x? You would add 3 to both sides. You would divide by 4. And then you would take the square root of both sides. we're going to do the same thing, only we're going to have sine squared of x, not just x. So we're going to add 3 to both sides. We're going to divide by 4. And we're going to take the square root of both sides. But remember, I didn't write the square root in the problem. You're having to take the square root. That means you have to remember that this could be plus or minus the square root of 3/4. Now, I'm not going to spend the time on the video showing you how to simplify this, but I do want you to know that this is going to equal plus or minus root 3 over 2. So sine of x is equal to root 3 over 2, plus or minus. So where on the unit circle is the sine of x equal either a positive root 3 over 2 or a negative root 3 over 2? Let's look at our unit circle, and you'll see that there are 4 places where the sine value can be either positive root 3 over 2 or negative root 3 over 2. And we have to write all 4 of those down for this problem. So our answers are theta is equal, x, it's x. X is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All 4 of those locations have a sine value that is either positive root 3 over 2 or negative root 3 over 2. Now, example 8b is just another one of these problems. We're going to do it exactly the same way. We're going to solve for theta. And so I'm going to add 1 to both sides. That's 2 cosine squared theta equals 1. Divide both sides by 2. So that's 1/2. And I'm going to take the square root of both sides. So that's plus or minus the square root of 1/2. Now, once again, I'm not going to spend a lot of time on this because we should at this point know how to simplify a radical. But that's going to be 1 over the square root of 2, which you need to rationalize as the square root of 2 over 2. Well, where on the unit circle is the cosine value, either positive or negative, root 2 over 2? And that's going to happen in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we're going to have 4 answers again. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Feel free to go back over this video and see if you can slow down, restart, work through the problems yourself. And if you're not sure where we got these answers, please be sure and come and see us.